Okay, factoring review. Always factor out the what first? Oh no. GCF. The GCF. Gosh. Gage, you must have had a good math teacher last year. You always factor out the greatest common factor first. Always. Even if there isn't a greatest common factor, you will still do these next three things. Even if you don't do a greatest common factor, you still go on to the next step. So this is always look to see if there's a greatest common factor, then move on. The next thing you do is decide how many terms there are. If there are two terms, there are two situations that you could factor further when there's two terms. After you've taken out the GCF, if there's two terms, you might have a sum or a difference of cubes, or you might have a difference of squares. Those are your only two choices when you have a binomial other than GCF. And we will review these in our notes today. If it has three terms, there are different methods that I know different teachers in this school teach. So I'm going to approach it one way. You might know it a different way, and I am okay with you using a different method if your method works. Do you understand? I'm okay with you using a different method if your method works. The method that I use for factoring three terms is called guess and check. If you use a different method, you can use that different method. This is the one I use, okay? And then factor four terms, we will call factor by grouping. We will do factor by grouping. All right. So example one. We're going to start by factoring out a greatest common factor. Then we're going to see where it takes us from there. So look at question A. Do we have a greatest common factor? What is it? X. We're going to yell those out for me so I'm not just like waiting all day for somebody to answer. We're going to factor that out. That means you do the opposite of multiplying it in. You're doing the opposite of the distributive property. Undistributing, which is division. You take that out, you put it in front, we have left over x squared minus 4x minus 5. That GCF has to go here, or you get the correct factored answer. You're unmultiplying, so it's still part of the product. So we take out our GCF. After we do our GCF, we now say how many terms are left? 3 terms. When you have 3 terms, you're going to factor it with 2 parentheses. And I'm going to show you my guess and check method. I always look at this sign. This sign tells me about my signs for the 2 parentheses. If the sign is a negative sign, that tells me I will have a positive and a negative. Because the only way I can multiply 2 numbers together and get a negative 5 is if one of them is negative. What happens if both are negative? It would be positive. So it has to be one of each sign. So now, speaking of that, what multiplies together to give me negative 5? The 5 part. It could be negative 5 and it could be positive 1, or it could be positive 5 and negative 1. You probably already know the answer, which is why you were saying that. What multiplies together to give me x squared? Okay, so x and x. I know it's going to be a 5 and 1. I'm going to go with it because I feel like I trust him right now. He says it's a negative 5 and a positive 1. But that is my guess. Here's my check. Multiply these back together. Negative 5 times x is negative 5x. 1 times x is 1x. Does that add to give me my middle, negative 4x? Yes. So now I've checked it. It is correct. After you do one of these methods, you have to go down to this bottom that is always the same. Always check binomial factors for more factoring. So we go and we look at all the binomial factors. Here's one, x plus 1. We see if it can be factored further. If it can be factored further, the x value, the x exponent, should go down, but it's already 1, so it will not be able to be factored further. This one is 1. It will not factor further. But we always need to make sure that these can, if they can factor further, we keep going. This can't, so that's my answer. Question B, what is my first step? Greatest common factor. Do we have a greatest common factor? Let's do it this way. Shivani. 3y cubed. So I pull that out, 3y cubed. I have what's left over, y squared minus 16. Jacob, how many terms are left? 2 terms. So I go up here and I say, do we have a sum or a difference of cubes? Okay, that wasn't my question. Do I have cubes? Why not? Because that's not a cube. Okay, so now we go, do we have a difference of squares? Subtraction. Are we subtracting perfect squares? Possibly. Are we subtracting perfect squares? Yes. Can I square root both of the things I'm pointing to right now? Yes. Okay. 3y cubed. And I'm going to open up 2 parentheses. When we have a difference of squares, we have 1 plus and 1 minus. That's how I get the minus 16. How do we get the y squared? I have y times y. How do I get the 16? I have 4 times 4. They are perfect squares. If you're not sure if that works, you can check it. You can check it by FOIL, which I did over here. There's another method you could check by, but this one takes me longer to check, so I don't usually use this one to check. Have you guys seen this one before? I mean, you can check this way too. Y squared, 4y, minus 4y, minus 16. These cancel, y squared minus 16. Yes, that's factored correctly. Okay. Ooh, I boxed it in, but I didn't go back and check. Do I have a difference of squares here? Like, should I factor this one further because it's got a 4? It's subtraction. It's 4. Why not? Ethan, why not? Because the y isn't squared. Okay. Question C. Isaac, what should I do? 5z squared, good. So we're going to factor out 5z squared, get z squared plus 6z plus 9. Okay, Zell, what am I left with here? 3 terms. Okay, so I'm going to use the guess and check method. You guys might know a different method like split the middle. But I'm going to guess and check. So guess and check says, go ahead and open 2 parentheses, and then I'm going to look at this last sign. When the sign is positive, that tells me that both of these signs are going to be the same. The sign that they will be comes from my first sign. Both be plus. I'm guessing and checking, so to get z squared has to be z and z. What could it be for 9? 3 and 3 or 1 and 9? Like, it could be either this for 9. I just have to figure out which one it is. What do you think it is? 3 and 3. Let's just make sure. We're going to say 6. No. 3z and 3z is 6z. Yes, I've done it correctly. Am I done? Hallie? I'm not? What should I do? The 2 binomials that are exactly the same. Yeah. So right here I've got z times z, and I do not write it z times z, because that's just silly. So here I do not write z plus 3 times z plus 3. We write 5z squared times z plus 3 squared. Very good. Let's just do one more. Can you guys do number 1? And then we'll move on to the back. You try it. When you've done it and you've checked it, flip the page over so I know you're ready to go on. And you've done it and you've checked it. Because I did put the answer. So, you look at the time. It's going to say that they're missing. That's great. So, it's going to say same time, it's going to 12%. That makes sense. Or, which you're looking at. Okay, so the middle comes from adding together, ASCII multiply, the end comes from multiplication. Is that what you're doing? Thinking the other way? Because I was thinking ahead. That is a big downfall that I have, is my brain is always like thinking faster than my hands write. So then I write what's currently on my brain instead of what was on my brain a millisecond ago or whatever. Okay. We move on. Again, try to stay away from just going into like autopilot and being like, factor cubes, this is what you do. Da, 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 done. Actually, cubes is kind of like that though. It's the factor by grouping I worry about. Okay, so factor the sum or difference of cubes. There is a formula, it's right here. And the explanation of this formula and my explanation of the formula is when I do this, and I notice that we've got 2 perfect cubes being added, I will square root those, and I'll write those in the first parenthesis, a plus b. That's how we're getting our first parenthesis. It's already written. I'm just explaining how I do it in like the order. For my second parenthesis, I go off of my first parenthesis. So I don't go back to the beginning. I go off my first parenthesis. And I take that a and I square it for the first spot, a squared. Then I take the b and I put it in the last spot, squared. It is always subtraction. The 2 multiplied together, the a and the b multiplied together. So that's how I get my middle spot. Okay, so once I have my first parenthesis, I use my first parenthesis to get my second parenthesis. And then there's some examples over here. We're just going to do some of these. Before we start, though, if you don't know like cubes off the top of your head, I'm just going to throw some out there so you could write some down. What's 1 cubed? Okay, what's 2 cubed? 3 cubed? 27. 4 cubed? 64. Let's see how fast you can do it. 5 cubed? 105. 6 cubed? 2. It's 216. Uh-oh. 7 cubed? 343. 8 cubed? 512. So nobody knows these, huh? 9 cubed? I know. 729. 10 cubed? 1,000. Yeah, all right, that one's easy. Okay. After that, I don't even know, so. All right, factor a cubed minus 20. So, I noticed this is a difference of 2 perfect cubes. So I'm going to start out by making my first parenthesis. It's going to cube root each of these, so it's going to be an x and a 5, and it's going to take the same sign as what my original was, so it'll be different. Then I make my second parenthesis. And to get my first spot, I just square the first number, x squared. My last spot is I square the second one. What's negative 5 squared? Oh no. What's negative 5 squared? Is that a positive or negative? That is a positive 25. And then the middle is always subtraction, and then we multiply together, it's negative. So that becomes x minus 5, x squared plus 5x plus 25. Yikes. Why? Did I just box that in? I didn't follow my own rules. It's not my rules, by the way. I didn't follow the factoring rules. What should I do before I box that in? We should see if it's done factoring, right? So what multiplies together to give me x squared? X and x. The signs tell me that they're going to be both plus. What multiplies together to give me 25? It's either 1 and 25 or it's 5 and 5. Which one's going to work here? You don't know? Oh, neither of them? Yeah. No, you're right. So here's a nice thing I'm going to tell you about cubes is this second one will never factor further. So if you'd like to save yourself some time, you know, I just had us think through it, but I was writing really lightly off to the side because I knew that it wasn't going to go. It will never factor further. The second one won't. So save you a little bit of time. The first one might. This one doesn't, but the first one might. The second one will not. Okay, 16 s to the 5 to the 5th plus 54 s squared. What do I do first? Austin, what do I do first? Always first. Is s squared the only thing? Let me answer my own question. Factor out the GCF. That's right. So we're going to divide out s squared, but is that the only thing they have in common? 8 doesn't go into 54. So when I was calling on you, I didn't really expect you to say the whole answer. I just wanted you to say factor out the GCF. I wasn't trying to put you on the spot for the answer. 8 doesn't go into both. What goes into both? Does 2 go into both? Does 16 go into both? No. Does 4 go into both? Does not go into 54. So 2, 2. That's convenient that it was 2 because now when I took out 2s squared, I'm left with a sum of perfect cubes. Oops. So I factor those with 2 parentheses. The first parenthesis is going to be plus sign for this one because it's a plus sign. And it's going to be the cube root of each of these. So 2s and 3. The second parenthesis, in my first spot, I'm going to square 2s. What do I get? 2 is not squared. I'm going to square 2s. 4s squared. Then I'm going to square 3 for my last one. 9. In the middle, I do subtracting. These two multiply together. 6s. Is 2s plus 3 factored all the way? Is there a GCF? Is it like difference of squares? No, this is s to the first power. It can't factor further. Is this factored all the way? Why can you say yes so fast to me? Because I already told you it will not go further. You can save yourself some time. Okay, so those are cubes. If you need more practice with those, I guess we'll do number 5. Let's just do number 5. You try. You try. You try number 5. I'll do it down here. You try number 5. I'll put the answer up in just a moment. That's why I was like pausing to figure out what she was doing. So did you get the greatest common factor if there's both of them? That number should be figured out there. Now we're good. I'll put my answer up. So make sure that if you do take out a greatest common factor, that it is part of the answer. And then make sure you take out the greatest common factor. If you took out just a 3 or just a 2, you wouldn't have been able to go further. You take out the biggest common factor, which is 6, z squared. Okay? All right, the last section is factor by grouping. I'm going to get at least one of these lunch. Factor by grouping is the one that has like all kinds of different multiple ways of doing it, but I bet you in Algebra 2 you only did it one way. So this is one where it's easy to go into autopilot and do it the one way you've learned, but then you can never use that to do other kinds because you've always only done it one way. So factor by grouping is literally like grouping some groups together and then using this instead of like as 4 terms, using it as like a binomial. So we're going to make 2 groups out of 4 and then we're going to treat it like it's a binomial. And the ones that you did a bunch last year with is grouping 2 terms with 2 terms together, and I'm going to put plus and negative right here so that I can group it with a plus sign in between. So this is kind of how you did it last year for the most part. I don't know how much honors does different kinds, but I know in CPE classes we really just did this kind. But this is not the only way you could do it. You could have grouped it like 1 and 3 terms. Like it could be uneven amounts, but then what we're doing is treating this like it's a 2-term problem. So we're gonna do some factoring of these individual groups, and then we're gonna treat it like it's a 2-term problem. So we're gonna go through our factoring rules for x cubed plus 5z. Sorry, that's a z. Z cubed plus 5z squared. What is our first rule of factoring always? Okay, is there a greatest common factor? Okay, so we'll take that out. Z squared. And we'll have z squared times z plus 5. And then I'm going to keep looking at the z plus 5, and I'm going to say, can I factor z plus 5 any further? No. So that's factored as far as I can. Now I'm going to look at the other parenthesis. My first rule of factoring is common factor. Do you see that? Okay. What is it? It is a negative 4 for this one. You see how they're both negative? I take out the negative 4. And I'm left with z plus 5. So now, can I factor z plus 5 any further? Okay, so I factored it as far as I can by groups. Now what I'm doing is I'm looking at this like it is a binomial where we have 2 separate terms. And we'll do our factoring again. What is our first step of factoring? Always. always. Is there a GCF? So the question is, the stuff I underlined, is there anything in common? The z plus 5. That is the common factor for the stuff that I underlined. So what I'm going to do is I'm going to factor out the GCF, which is now something in parentheses. I'm going to factor that thing out. When I factor that out, it cancels, and what is left over? When I divide it out, what's left over? Saved by the bell. Just kidding. We'll finish this when we get back. What was left over after we factored out the z plus 5 is z squared minus 4. Okay? You still have to factor if anything is still factorable. Do you know why I'm circling my thing around here? What is this? What is the kind of factoring? What kind of factoring is that called? Do you know? Difference of squares. So we just want to factor completely. We want to factor all the way. There's two examples here. I'm going to give you a moment to try them. I'm going to give you like a third example that would be like a challenge. If you are like, oh my gosh, this stuff is so easy, I've been doing this forever, and you want something that is a challenge, it is a factor by grouping question that's different than these. So I'll put a challenge right here for you. But I want you to go ahead and try at least one of 6 and 7, if not both, if you need the extra practice. So you guys, we're just doing the two groups together, but you have to have a plus sign in between or this factoring doesn't work correctly. Because this is something plus another thing, we're making it into two groups. For this, there's a GCF. And then over here, I have a GCF of -1. So we now have a binomial, which is two terms. That's why I kept that plus sign in between, so we could have a binomial, two terms. And now I'm going to factor out that x plus 4, which goes in front. And then what's left over after I factor out the x plus 4, I have x squared minus 1, which is a difference of squares. X plus 1, x minus 1. For number 7, we're factoring, and we have to have a plus sign in between so that we can factor out y squared, and we're left with 3y plus 1, and we're going to factor out 3, and we're left with 3y plus 1. So I still have that plus sign in between. It does not seem significant, but it's there so that I have a binomial. Sorry, I was off the screen a little bit. So then this would be the answer. Okay, the last 4 are, and if anybody tried this one, I'll come around and look at your answer if you tried the challenge. But the last 4 are factoring in quadratic form. However, you'll notice that they are not quadratic. Like this one is not quadratic. It is not squared. But it's in that form that we would do the squared with. First step, GCF. Is there GCF? Is there greatest common factor? Bless you. What goes into 16? 4s, 2s, 8s. What goes into 81? 3s, 2 does not go into 81. 9's 27. Do they have anything in common? Nah. No GCF. I still go to my next step that says this is a binomial. Is it cubes? No, that's to the 4th power. Is it squares? Is it a difference of squares? Can I square root 16? Can I square root x to the 4th? Yes, it'll be x squared and x squared. Can I square root 81? So this is a difference of square. Just because it's to the 4th power doesn't mean it's not a perfect square still. So we're going to have 4x squared plus, 9. 4x squared minus 9. Is that factored all the way? Can I factor 4x squared plus 9 any further? Should I split this one up? Darren, why do you think now? Because I'm pausing?
Because you can't, I don't want to say get the middle, but I mean.
If I split it up,
Yeah, you can't with the 4x squared minus 9.
if I split it up, I know exactly what you're saying. If I split it up and then I like FOIL it back together, there's no way the middle's going to cancel out. I could do negative and negative to be a positive 9, or I could do positive and positive to be positive 9. But that middle's not going to cancel out. This you cannot factor further. There is not a sum of squares. There is only a difference of squares. So 4x squared plus 9 stays. But then 4x squared minus 9 becomes 2x plus 3 and 2x minus 3. So again, these are in quadratic form. 3p to the 8th plus 15p to the 5th plus 18p squared is their GCF. Michaela, is there a GCF? 3? P squared. Okay. I'm left with a trinomial. If I have trinomial, it's the guess and check kind. So I'm going to make 2 parentheses. According to this sign, this tells me they're both going to have the same sign. What sign should they be? Right. I'm going to look at p to the 6th. What can I possibly multiply together that will give me p to the 6th? What do you think? I think you're thinking just multiplying numbers, but we're multiplying p's. Oh, not to get to the 6th. To get p to the 6th. Yeah, to get 6 would be 1 and 6 or 2 and 3, for sure. But how do we get p to the 6th? And in the middle, we have p to the 3rd. Del, you got an idea? There's something out there. What times what can give me p to the 6th? Okay, so if I do p to the 2nd and p to the 3rd, if I do p to the 2nd and p to the 3rd, that's going to be 2 p's here, and that's going to be 3 p's here. When I multiply it together, I'm only going to get 5 of them. So what we're going to say second? Okay, so p cubed and p cubed. And you know why it's p cubed and not p to the 2nd and p to the 4th? Well, it could be p squared and p to the fourth. It could, but what's the middle? P to the third. So when I do my outside and my inside, when I go and I multiply those back together, I need them both to have p to the third. Otherwise, they're not going to add up together. They're not going to be common, like terms. Okay, so now am I going to use 1 and 6 or 2 and 3? 2 and 3. And we can do what I just drew, a little check it. It does work, but now we got to see if these go further. Do we have perfect cubes? Is this perfect cubes? Paige? Why not? I see p to the cube right here. P cubed. The 2 is not a cube. Right. Check it. And then what about the 3? Is that not a cube either? Is that not 1 times 1 times 1? No, it's not, right? Just checking. Done. How about you try number 8? You try number 8. I have a different one for number 9, so don't try this number 9. I have a different one. Where did my number 9 go? Okay. I have a different number 9. How can you try it if your pencil's not in your hand? Oh, you've already done them? I've already done them. Oh, there are people not doing it. So, would I be okay for you to use your calculator on something like 625? Yeah, I'd be fine with that. It'll slow you down if you don't know it, but in the long run, I guess it might speed you up. Don't know it. Okay, so I do have some people stuck on the first one. And I think the reason why you're stuck is you're not thinking of the very first step. What is the very first step? Is there a GCF? There is. What is it, Gage? Okay, if I take out -1, that does not change the value. All it does is switch the signs. So we actually chose to do this to help us in the long run. Now, I did see some people on their paper did not do what I just did. All they did was rearrange the terms, which is also okay. Your answer will look different than mine, but it will work out exactly the same that mine will. So then from here, this is a difference of squares. And then once you have that factored, 4n squared minus 25 factors further. And I put them in a weird order, but that's okay. It's the last one that I'm mostly worried about. Can you try the last one? And I'll start hitting out your assignment. You haven't tried it. That we have like on our homework, and I want to make sure you guys can do it. Is there a GCF? The last one, is there a GCF? Yeah? Okay. You're trying to do it without having to erase. You're trying to do it because you don't want to erase. This is what I should see going on your paper, right? There's got to be one positive and one negative. What? What'd you learn from last year? Yeah, that is a method you could use. I do that in my head sometimes to help me do it. Zell, are you doing anything over there? What makes 6x squared? What makes 6x squared? 3x and 2x? Or 6x and 1x? You see there's the opposites. What makes 4? Or minus 4, really. What makes 4? 2 and 2, or 1 and 4? Or it could be like the 1 could be with this one and the 4 could be with this one. Like this one's hard because you have to try stuff and it might not be the right thing right away. So let's say I say 3x, 2x, 2 and 2. I add these back together and I get 6x and I get a 4x. There's no way I'm getting a 23 from that. So then I need these numbers to be bigger. So I'm thinking I should probably use the 6. Maybe I do 6 and 1. So I tried the 6 and the 1 and I get like a 12 and I get a 2. That's still not big enough. I want to add these together to give you 23. So then I'm thinking and I'm saying maybe I have 6 times the bigger number 4. And I put my 1 here. So you have to like mess around with these sometimes. This is going to give me an x and this is going to give me a minus 23x. And now I realize I've done something wrong. What should I have instead? Yeah, I should have a plus here and I should have a minus here. That's going to give me a plus and a minus and that's going to work. So you are going to have to finagle some of those. That's guess and check. Okay? Your assignment is that worksheet that I handed out.